Hello, Spark Summit. I am super excited to be here today to talk about some exciting developments in the growing Apache Spark ecosystem. But before I get into that, I want to talk about something I read last week on the internet. So what you see up here is a tweet from Urs Holtz, who's the senior vice president of technical infrastructure at Google, and he's telling us that MapReduce is dead. And I thought that was pretty interesting, since MapReduce was really kind of the foundational technology that's the reason that we're all here in this auditorium today. And as he says, it was a seminal idea, but they found easier ways to express their problems and also to do things like unify streaming in batch. And I want to kind of flash back in time and look at why MapReduce was such a cool idea and what this means for Apache Spark moving forward. So, of course, when MapReduce was created, this was not the first time we started using software to manage large amounts of data. Data warehouses have been doing that forever. So what was different with Hadoop MapReduce? Well, to me, one of the most important things is the separation of compute and storage. And this is actually even more important today with the cloud. This separation means that when you have changing needs for your cluster, you don't have to go through the really expensive process of moving data around. You can just start up more machines, and at night, when you have less computing needs, you can shut them down and stop paying for them. And that's really powerful. That kind of fundamentally explodes the database and changes the way you work with it. Another thing here was, while I think SQL is a great language, MapReduce was actually a much more natural way to express things like AI. It turns out there are some things that are very difficult to express in SQL, and being able to do that in Scala, Java, Python was much easier. And finally, I think you can't discount the importance of open source. There were databases that could store petabytes of data, but open source Hadoop MapReduce really unlocked the ability to process petabytes of data efficiently for everybody in the world. And I think that's really, really cool. But of course, Hadoop MapReduce was not a panacea, and the database graybeards let us know about that. So here's another article from 2008 entitled MapReduce, a Major Step Backwards, where two database luminaries, David DeWitt and Michael Stonebreaker, argued that MapReduce was one step forward and two steps back. So what was wrong with the MapReduce idea? Well, so I think one of the big things was it didn't have SQL. While SQL is not great for everything, SQL is great for a lot of things. And the really powerful thing about SQL is it's a declarative programming language. That means you're telling the computer what you want rather than how to accomplish it. And the database query optimizer is responsible for figuring out the best way to solve that problem. And that not only frees you up to do more interesting things, but it also makes your programs robust to changing data sizes and changing number of machines and other things. So it's a really powerful technique. Another thing is a data model and a catalog. With Hadoop, you just have this big file system. And so you don't know if this column is a date and if it's not supposed to have nulls in it. It's very difficult for you to find things in a large organization when you're just sifting through all of these different files. And this was really, I think, made it much more difficult to work in a large organization with data. And then finally, my favorite database magic trick, ACID transactions. What does this mean? What do ACID transactions do? To me, they take away two of the hardest problems in computers, which are failures and concurrency, and they make sure you don't have to think about those anymore. The A in ACID stands for atomicity, which means that when your programs run, they either run completely or not at all. And if something goes wrong in the middle, you don't have to worry about corrupting your data or cleaning things up. The system just takes care of that rollback for you. And the C and the I, consistency and isolation, mean that when you have multiple people modifying the same data set, maybe even using streaming in batch, you don't have to think about that concurrency. It's as though you're happening one at a time, even though they're actually happening at the same time. And that's really powerful. So how does Spark fit into all of this? Well, of course, from the beginning, Spark was inspired by Hadoop. So we had the top three categories. And I actually got involved with the Spark project back in 2014 when we started to create Spark SQL. And that gave us the power of SQL and optimization. And once we did that, that really unlocked something really cool. And ever since then, people in the community for Apache Spark have been trying to fill in the rest of these checkboxes. And so in the talk today, I'm going to talk about Spark 3.0, which improves the Spark SQL optimizer and also brings a new federated catalog to Apache Spark. I'm also going to talk about another open source project called Delta Lake that brings ACID transactions to your data lake. And finally, as a bonus, we're also going to talk about data science at scale and Koalas, how it can take your Python programs and automatically run them in parallel using Spark. So what you're going to see is the Spark ecosystem is really exploding, and these three things are going to kind of fill in all of those missing pieces. So starting off with Spark 3.0 and the improved optimizer and catalog, one of my favorite features here is Data Source v2. Why should you care about Data Source v2? It is a pluggable catalog for Spark. So now Spark can not only read data, but can also find all of those data sources that exist out there in your organization from a variety of different data sources. It has improved pushdown, which means faster queries. Spark will actually tell these data sources what data is relevant to the query and make sure that you don't have to ship unnecessary things over the network. And finally, since Spark has always been a unified system, this is the first public stable API for building unified APIs for both batch and streaming. So I think this is a really cool development. Moving on to query optimization, we have another feature called adaptive query execution, which solves one of the key problems in data lakes. In a traditional database, you have this thing called the closed world assumption, where the database owns all the data, and so it can have accurate statistics. However, in a data lake, you might be reading from anywhere. You might not have accurate statistics. And that means sometimes the system might make suboptimal decisions. So in this example, I'm reading from a large table and a small table, and Spark is going to initially do something that's fairly expensive called a sort merge join. And what's going to happen is partway through execution, it's actually going to realize, hey, one of these tables is really small, and it's going to change the execution plan at runtime and switch it to a broadcast join. And what this means is there's no more expensive sort, and your query is going to run faster. And in industry standard benchmark TPCVS, this speeds queries up by up to 2x. Pretty cool. If you like that, there's more. So another really powerful optimization is dynamic partition pruning. This is the bread and butter of traditional data warehouses, and we now have this power in Spark. So very similarly, joins are one of the most expensive things you can do, and we're going to make them faster using a different trick. In this case, we have a very large table, a fact table, and we have a dimension table that we're joining with. And there's a filter on that dimension table, but it's not helping us filter that really large fact table. What dynamic partition pruning is going to do is it's actually going to use that information from the right side of the join to filter stuff on the left before you even read it. So it's going to make that join significantly cheaper. And there's actually a talk later today on this, so if you want to know all of the gory details, you should definitely check that out. But altogether, what this means is Spark 3.0 improves TPCVS performance by as much as 17x, which is crazy. And what someone has done with this, the Alibaba group, actually competed in the TPCVS benchmark, and they now hold the top spot for performance in the world using Apache Spark, which is really cool. And there's a lot more in Spark 3.0. I don't have enough time to cover it all, but there's going to be a preview coming out this quarter. So if you want to learn more, I suggest you join the dev list, get involved with the community, and help us test out this preview release of Spark 3.0. So moving on to the next thing, Delta Lake, which brings ACID transactions to Spark. I want to start by motivating it about what's hard without ACID transactions. So I'm going to talk through a problem that I'm sure a lot of you have actually had to solve yourselves. You've got a lot of events coming in from some data source like Kafka, and your boss has given you two missions. You need to do streaming analytics, so you can figure out what's happening with your business right at this very moment. And you also want to do AI and reporting, so you can do longitudinal studies and actually make predictions and trends and figure out what's going to happen in the future. Now, I might be a little biased, but when I start to do something like this, I would use Apache Spark, which is a unified engine for both streaming and batch. But is it really that easy? Unfortunately, Kafka is a great technology. I love it, but it's great for storing a day, a week, maybe a month of data. It's not great for storing years of data. So I read a lot of blog posts, and the way a lot of people solve this is they switch to this thing called the Lambda Architecture, which, as far as I can tell, means you just do everything twice. You have a streaming system and you have a batch system. We've got Kafka and we've got HDFS. We have to run everything twice, but we're good engineers. We can do this. And again, Spark has unified API, so it's not that bad. But it adds a little bit of complexity to our system. So we're all good now, right? Well, it turns out your data is definitely messy. As soon as you start collecting large amounts of it, there's going to be some problem where someone upstream from you changed the date format without telling you, and now it's parsing into null. And so you need to do a whole bunch of validations. And the file system doesn't help you with that, so you actually have to write a whole bunch of other Spark programs to do those validations. And since we're doing the Lambda architecture, we got to do it in both streaming and batch. But again, we're good engineers. We can take care of that. And that brings us to the next problem. Sometimes you forgot a validation, and bad data made it into your data lake. And again, the file system doesn't help you out here. You have to write Spark programs that are going to fix that. And so here's a technique that I'm sure many of you have done. You take your data lake and you break it up into partitions, days, months, hours, whatever makes sense for your business, and you build an engine around it that can do reprocessing. And these partitions are nice boundaries to do that reprocessing by. So when something goes wrong, I'll just delete that entire directory and recompute it from scratch. So again, a bunch of infrastructure I have to build, but I can solve this problem. And that brings us to the final challenge, which is updates. Partitions are great, but they're not going to help you when GDPR happens and somebody asks you to remove every trace of them from your entire data lake. You're not going to recompute all those partitions from scratch. So you're going to have to write a new set of Spark programs to do that cleaning. You're going to have to be really careful because you don't want to corrupt your data in place. And also, if people are reading the data while you're modifying it, they're going to get bad errors. You want to be very careful about scheduling. Do GDPR on the weekends and only run analysis on weekdays. Make sure to shut down that data lake. And the theme here is you end up wasting a lot of time and money solving these well-known systems problems instead of doing what you really want to do, which is extract value from your data. So let's take a look at what this looks like with Delta Lake instead. We're going to take this relatively complicated architecture, and we're going to switch to what we really want to focus on, which is incrementally improving the quality of our data until it's ready for consumption. With Delta, a lot of people start following this pattern. You do capture all of the raw, dirty data in bronze, you clean it up in silver, and then finally you create gold tables that have business-level aggregates that mean something to your business. Why can you do this? Well, it's because of the power of full ACID transactions. The atomicity, the consistency, the isolation means you can focus on your data flow instead of worrying about failures and other people modifying the data at the same time. And of course, Delta Lake is powered by Apache Spark. It unifies streaming and batch, so you can use it no matter which APIs you're using, and you can convert your existing jobs with minimal modifications. You just change the word Parquet or JSON or CSV to Delta. Another pattern that I see a lot when people start using Delta is they start switching to streaming. And you might say, you know, I don't have a real-time use case. I don't need all that complexity. But I actually think that's not how you should think about streaming. To me, streaming is solving the problem of incrementally computing an answer over time as new data arrives, which is pretty much everything we do in data engineering and data science. Nobody has a static data set. And what streaming does is it takes away this really hard problem of figuring out what data I already saw, what's new, how do I take that new data, process it exactly once, commit it downstream while maintaining exactly once semantics, even in the case of failures. And I want to checkpoint my state so that I can restart automatically if something goes wrong. Streaming does all of that for you. So even if you have a job that you only run once a week or once a month, streaming is a really powerful tool to improve that. And Spark has the cost latency trade-offs that you can kind of make automatically in the APIs. Now, of course, Delta Lake is not only about streaming. We have full support for batch as well, because batch jobs do happen. You maybe need to do retention once a month, where you kind of clear out data that's older than 2 years. You might have change data capture or GDPR, and Delta can support all of those use cases as well. So we actually just open sourced Delta last April at the Spark Summit in San Francisco, and the community has been exploding. So you can see we have over 20,000 downloads last month. There are over 4,000 organizations, almost 4,000 organizations using Delta, and we processed over 2 exabytes of data last month alone, which is a crazy amount of data. And the community, I know this is a Spark conference, but the community around Delta is growing as well. So there's a pull request from Alibaba to add support for Hive, and Starburst announced that they're going to be adding a reader for Presto as well, which I think is really cool. And this actually brings me to my announcement, which is anybody can make an open source project by just slapping a license on it and putting it on GitHub. But with Delta, we really want to build a community, and we want to make this the standard for storing massive amounts of data in a data lake. And so I'm really excited to announce that Delta Lake is going to be joining the Linux Foundation. We're really excited to have the Linux Foundation as a permanent vendor-neutral home for Delta so we can continue to grow the community around it. OK, that's been a lot of talking, and this is a Spark Summit, so I know you guys want to see some code. So I would like to invite Brooke to the stage to show you how cool Delta and Spark work together. Thank you.
All right. Hello, everyone. Super excited to be here. So Oktoberfest was just a couple weeks ago. Millions of tourists went to Germany and drank more than 7 million liters of beer. So what you may not know was that during that time, there were a group of Databricks engineers who spun off a new brewery called Databricks, and just in time for Oktoberfest, and they launched this new type of beer called AI beer, or pronounced A beer. So what we would like to do today is using the last 2 months of data on their sales, and we would like to project how much they're going to sell over the next 2 months. So let's go and get started. So what we're going to do first, we're going to plot. We have some. Before we do any of that, let's go over our data architecture. And if the Ethernet's connected properly. But in our data architecture, we can see that we have our traditional data warehouses where we have siloed data. This could be regional data, sales data across the globe. And then on the other hand, we have some common storage formats such as JSON and CSV that's being uploaded to cheap storage. So this data is unified in a data warehouse. We use Hive for that. And within this data warehouse, you find all types of tables around. You can find raw JSON data. You can find aggregate sales data, where you have the final aggregates over time. This is where we generate all our reports for our end use cases. And you can also find regional sales data that was pulled in from the traditional data warehouse. So in order to do our forecast, what we're going to do is we're going to look at our aggregate data first and see if we can generate a forecast on top of it. So let's go back and do a plot of select date sales from sales all ag, where brand equals AI beer. Interesting. So, we have our data. We do see an uptick during Oktoberfest. This week is when, in the US, they always celebrate Oktoberfest in the last week of September. But we're missing a week of data. And if we try to generate our forecast on this, it'll bias our sales forecast pretty high up. We want to know what's actually happening in the last week. This data could be delayed for several reasons. When you're aggregating from multiple siloed data sources, you might have failures in your ETL jobs. Or there might be like some GDPR deletion that's delaying the updates of our latest data. So, okay, maybe I can't use this to generate this forecast. But I have my raw data, and that should be up to date. So let's take a look at that. So select date sales from sales raw, where brand equals AI beer. Listing partitions, approximately 17 minutes remaining. Coffee? Anyone? Well, there's got to be a better way. We've all been through this. This is the kind of queries which takes such a long time that you would go out and get some coffee. But, there are better ways to do this, so I'm just going to cancel this. As an alternative, what I can do is I can aggregate the data from my regional sales tables. So I'll do that. But in order to do that, I'm going to create a delta table. I'm going to say create table, sales ag, date as a date, as not null, double not null. As you can see, I'm adding these not null comments around my columns. What this will ensure is that as I'm adding data to my table, I'm ensuring that the fields will be not null. Because if I'm generating a forecast and I'm aggregating over null values, you don't want that to happen. That data will be lost. creating a Delta table. So as this command is running, what it's doing is it's creating a transaction log. And with this transaction log, all operations on this Delta table will access and use this transaction log as a single source of truth. What this will provide is that it will provide atomicity, consistency, isolation, and durability on all your operations. And as Ollie mentioned, we like to call Delta Spark and Acid for this. So what we're going to do on top is we're going to insert our data from our regional sales tables. So select, and they called it DT this time, so I'm just going to call a toDate function on it, just to be sure. Sales EU, where brand equals AI beer. I'm going to union this with my US data. Select from sales US. Oh, table. Yes, thank you. See, interactive demos are a lot more fun. And oh, it just said the invariant not null was violated for date. That's interesting. So we were just trying to write some null values into our table, but Delta just protected us. So let's take a look at where this is coming from. So let's look at our EU data. And this seems to be fine. I mean, this looks good to me. I mean, the dates are all there. So let's take a look at US data instead. And oh, this is where all the nulls are coming from. So why is that? Why is my toDate function not working? And of course, date formats strike again. It's in month, day, year format. You know, you have standards for a reason, but I mean. So let's go and fix this. Month, day, year. And OK, now our data is all ready. So thank you, Delta, for saving me there. So let's go and select date. We're going to sum our sales this time, since we're aggregating from sales ag. Group by date, order by date. And there we go. So we do have the latest data, and we do see a dip after Oktoberfest, so that's great. We can generate our forecast on top of this. So forecast equals true. And OK, we've got a nice forecast for the coming 2 months. And what you can see is that within the next month and a half, we're not even reaching, Oktoberfest levels again in our consumption and sales. So maybe these engineers should get back to coding. So to recap what we did today, Delta Lake, at the core of your data lake, can provide you many guarantees. So we very simplified our ETL. We just used purely SQL. We got ACID transactions. We didn't have to worry about garbage data, partial failures, none of that corrupting our data lake. And we got access to the latest data and accessed it through our tool of favor. And all these ACID transactions and schema enforcement kept the quality high in my data lake so that I could actually generate a very nice forecast on top of it. So thank you very much. There will be tutorials on Delta Lake. We have 4 tutorials. Each tutorial will repeat. These are at 11 and 11:50, and on Thursday, they're at the end of the conference. So it'll be the last 2 sessions. So check them out. Thank you.
That was a pretty cool demo, huh? Really shows the power of Spark and Delta together. I want to talk about one more open source project, though, before we close out this talk, and that's Koalas, which brings the power of Apache Spark to Pandas. The problem is basically this. Data scientists around the world build lots of code on their laptops with small sample data sets. You can see something like this, where we're loading in some CSV data and doing some computations on it. But then you realize, actually, I can't train my algorithms on small data. In fact, Google showed that more data actually does better than more sophisticated algorithms in many cases. So we need to scale up. Does that mean I have to rewrite everything from scratch? And before, that was true. But with Koalas, actually, all you need to do is switch pandas to koalas. And Koalas even has integration with Delta, so you can read all of that data directly from your Delta Lake at scale. The Koalas project is actually also a relatively new open source project. It was also open source back in April, and it is exploding in volume. So there were over 10,000 downloads per day, and it's growing 100% month over month. So I really encourage you to kind of join this community and get excited about it. But before I move on, I want to show kind of one use case that I thought was particularly cool, and this is the Virgin Hyperloop 1. So for those of you who aren't familiar, a Hyperloop is a really, really fast train. Basically, the idea is they take a tube, and they suck all of the air out of it. And rather than having tracks, they have magnets. And so as you can imagine, there's a lot of kind of physics simulations and other things that need to happen to make sure this whole thing is going to work. And the engineers at Virgin actually had built a bunch of their analyses using pandas and Python. And they found their kind of main limitation was computing time. Everything was taking way too long to run. They had a bunch of spare computers lying around that they couldn't use. And they struggled to switch this massive amount of code to Spark. And this is actually a pretty cool story for Koalas, because they were actually able to switch it all over, changing only 1% of the code, and get a speed up of 10x, which is crazy. That's pretty awesome, with only having to make minimal modifications. So if you'd like to get started with Koalas, it's super simple. It's available on all of your favorite Python package managers. You can pip install Koalas or conda install Koalas. And the documentation and all the source code is up and available online. But again, that's enough of me talking. I want to welcome to the stage Brooke, who's going to show you the power of Spark and Koalas together.
Hello. I'm very excited to demonstrate to you the power of Koalas. As Michael has mentioned, Koalas allows you to scale your Pandas code on Spark with very minimal code changes, taking advantage of the best of both ecosystems. To motivate Koalas, we're going to look at a very important and critical task. Let's dive in. For those of you who don't know, this is a map of Europe. And for those of you who recognize Europe, the color coding on this map corresponds to the alcohol belts of Europe. It's a real thing. There's a Wikipedia page. You can check it out after this talk. As we're in the Netherlands, which is part of the beer belt, I need to figure out which beer I want to drink tonight at the Summit attendee meetup. So, as any data scientist, I need to make a data-driven decision. So to answer this question, I'm going to analyze a beer reviews data set from Beer Advocate. So I'm going to start by setting up my workspace. And then I'm going to use my favorite data science tools, including pandas. So I'm going to start by trying to load in this data set. You'll notice the code is a little bit complicated, having to glob together multiple files. It might run out of memory, and it could take so long that you might actually need a drink by the end of this demo. So let's cancel this query. Instead, like any other data scientist in my shoes, we'll start by doing some exploratory data analysis on a subset of our data. So you can see here we have multiple features, including brewery name, a beer style, beer name, and the overall review for that beer from a given user. So I like to start by educating myself on what are the most popular beer styles, sorting by the highest average review. And we can actually see that the top beer style for our subset of our data is wheat wine. I thought this was a beer data set. And so this probably happened because we're only looking at a subset of our data. However, because loading in our entire data set is impractical, I think we've hit the limits of what we can do with pandas. Now it's time to switch into koalas. So to get started with koalas, all you need to do is install the library and import koalas as KS, replacing any of your PD logic with KS. Furthermore, we can take advantage of some Spark functionality or some common tasks in Spark, such as reading in from Delta tables. So here, we can easily load in our entire data set. Now I'm going to go ahead and run the same query again, this time figuring out the highest average reviews across our entire data set. And as you can see, the results are actually very different. And this is commonly the case when you have to subset your data set to do some analytics. But it doesn't have the beer styles I would have expected as the top review. I would have expected maybe an IPA to be up there. And that's because this query doesn't take into account the number of reviews. So let's do that down below. Unfortunately, I forgot the Python syntax to add in the count of reviews. But luckily, from my database classes, I can't forget my SQL syntax. And because Koalas leverages Spark under the hood, I can actually execute SQL against my Koalas data frame by passing in my data frame name in curly braces. And so now I can see, actually, the most rated beer is an IPA. It just doesn't have the highest average review. From looking at this data set as well, I can see that a lot of people had bought and rated fruit and vegetable beers, but it didn't have a very high average rating. Perhaps they needed to take a look at the data before they made their decision. All right, so continuing on with our exploratory data analysis. So in addition, we can do some date pre-processing steps using koalas. And we can easily extract out the year and month from our review time, so we can answer questions such as, what is the average review by month on our data set? Furthermore, one of the biggest issues when working with big data is how do you visualize and how do you plot that? I'm pleased to announce today that Koalas allows you to visualize all of your big data without the need to downsample any of your data sets. So we can take a look at what is the average review overall, month over month, on our data set. So here we can see our average review month over month, and we can see that in the years of 2002 through 2012, our average reviews are quite constant. It's about 3.8. But in the earlier years of our data set, there's a lot of fluctuation. As a data scientist, it's my duty to dig into this data to understand why there is so much fluctuation in the early years. So now I'm going to tweak this query and plot the cumulative sum of reviews for our data set to see what was happening in those early years. And we can see that there are very few ratings in our early years. So any reviews could have significantly changed that average. All right, so the most important question from this demo is, which beer should I drink? So as we're in the Netherlands, I'd like to select a Dutch beer, Heineken, Amstel, or Grolsch. From my previous analysis, I'd also like the beer to have at least 30 reviews since 2002, and then I want to get the top-rated beer from that set. So you can see here, I've already written the pandas code to analyze on my subset of my data frame, and I can go ahead and run this query. The top beer only has an average review of 3.35. I think we can do better on our full data set. So all I'm going to do is replace my pandas data frame with my koalas data frame and rerun the same code. You'll notice I didn't have to modify any of the other lines of code. Drum roll, please. Any guesses on which of these three it's going to be? All right, it's going to be a Grolsch Premium Weizen tonight with an average review of 3.91. So as a recap, Koalas allows us to scale our pandas code on Spark with very minimal code changes. We can take advantage of the Spark ecosystem, query our data using SQL, and visualize massive data sets, all without needing to downsample our data set. Prost, and looking forward to seeing all of you tonight.
Thank you, Brooke. That was another spectacular demo. So I just want to summarize what we saw today. The Apache Spark ecosystem is exploding, and it's bringing together the best characteristics of the data lake and the data warehouse. Spark 3.0 is going to be the fastest, best Spark release ever. Delta Lake brings ACID transactions into this ecosystem, and Koalas means even existing Python code can take advantage of all of this really cool technology. There's one other really exciting announcement tomorrow, so you'll have to wait for come back tomorrow to see that with Matei on ML Flow. And with that, thank you very much. I hope you enjoy the rest of the conference.